So this is example 1 for the binomial probability distribution chapter. A survey found out that 1 out of 5 Americans say that they have visited the doctor in any given month. 10 people were selected at random, and we want to find the probability that exactly 3 would have visited the doctor in the last month. First, let's go over the conditions for the binomial probability. The procedure needs to have a fixed number of trials, which we have because we have exactly 10 people. Then those trials need to be independent. So here we're going to assume people are independent, so we need that condition. Each trial must have just a binomial outcome, just 2 outcomes. So here they either visited the doctor or they didn't visit the doctor. There's no in between. And we assume that the probability is going to stay the same for every trial, which is our last condition. So the number of trials is 10 people. Probability is 1 out of 5, which in decimals is 0.20. That would make the probability of failure 1 minus p, 1 minus 0.20. That is 0.80. And the number of successes is exactly 3. So probability that x equals 3, I have my formula here. So 10 factorial, all of this divided by 10 minus 3 factorial, 3 factorial. Here we're going to have 0.20 to the power of however number of successes, so 3, 0.80, 10 minus 3. So let's continue with this. So let's expand the factorial. So it's going to be 7, 6, 5, 4, 3, 2, 1. So 10 minus 3, that's 7. This is this part. And then I'm going to do this part, which is 3 times 2 times 1. 0.20 to the power of 3. So I just Googled TI-84 calculator online. 0.20. We're going to elevate it to the power of 3. So we use this little caret symbol and it immediately opens the power here. So 3, enter. 0.008. Now let's do 0.80 to the 7 power. Now I need 0.80 to the power of 7. And I'm just going to use the first 3 digits. 0.209. Now I'm going to go ahead and cancel everything from 7 to 1, 7 to 1. Why am I able to cancel this? Because they're the same in the numerator and denominator, so this is basically just 1. So that leaves me with 10 times 9 times 8, 3 times 2 times 1, 0.008, 0.209. When we multiply 10 times 9 times 8, that's going to be 720. And the that's going to be over 6. 0.008, 0.209. And finally, we multiply all those 3, and we're going to get the probability that x equals 3. That is 0.201. We can also solve this problem by using the supplemental table that I put in our learning module. So the structure of it is pretty much the same, it just has more probabilities so that you don't actually have to use the formula. It has more probabilities, it also has more trials. So we're going to go down to the next page to n equals 10. We need exactly 3 and our probability was 0.2. So there it is. That's what we were looking for.